I'm so excited to be here today for GroupBy 2020, the October edition. So I'm sure if you guys have been hanging out for any of the other presentations, we do have a code of conduct in force today. Not going to go over this in detail, but basically just be nice to each other, all right? So anyway. Okay, so this is Advanced Plan Explorer usage for tuning execution plans. Again, my name is Andy Yoon. Blah, 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 blah. Here's some bio information about me. Really, the only thing that's important here is to understand that, I've been working with SQL Server for quite a while. I'm a former DBA, former dev, longtime user of Plan Explorer. In fact, Plan Explorer just celebrated its 10th birthday. So it's something that's been around in the community for quite a while. In either case, the only other thing that's really important on this particular slide is my contact information. I'm fairly active on Twitter. My email address is down there. I try and blog, even though I don't really blog as much as I used to. But in either case, my door is open. I love talking to people. I love engaging with the community. All right, so let's get on with the presentation and let's dive on in. But before we begin, I must address something. I like to call it the elephant in the room. This presentation is all about something called Plan Explorer, which is a completely free product, mind you, but it is made by a company called SentryOne. And as you can see from this shirt, I also happen to also work for SentryOne. So here's the thing. I want to assure everyone in the audience that this is not a vendor presentation. This is not a marketing fluff presentation or a sales presentation. I have specifically built this as a community presentation. In fact, my ideal audience are people who already use Plan Explorer. I'm not, here to try and convince you that Plan Explorer is awesome. Ideally, you guys already use it and think it's awesome and are here to learn more about it. So my promise to you is that in the next 60 to 75 minutes, that I'm not going to be getting into any kind of salesy or check out our paid products, all that kind of nonsense. This is a community session. Even though I may work for SentryOne, again, no vendor nonsense or nothing like that. This is community. So that's my promise to you. Okay. With that being said, I want to be also very clear about today's goals. My goal for this particular presentation is to really help augment your existing knowledge of using Plan Explorer. And Plan Explorer, in my opinion, is all about perf tuning your code and how to really get into root cause of what's misbehaving inside your execution plans. So hopefully, after this presentation, you're going to learn some cool tips and tricks or other usage scenarios, so that way you can speed up your use of Plan Explorer. One of the reasons why I love it is the ability to drill in rapidly. But frankly, it's a very dense tool, so sometimes you just you need to know where to look for stuff. And that's some of the stuff I really hope to be able to teach you today. This presentation is about 95% demo. There's a handful of slides up at the beginning and a few reference slides at the end. And as I kind of said earlier, this presentation is for people who already use Plan Explorer. So to be clear, I will not be covering basics. The other thing I also want to make sure that I state here is that I'm also not covering how to fix your execution plans. This is all about using Plan Explorer to get into your execution plans. And I'm going to be covering a handful of common scenarios, but I'm not necessarily going to teach you how to fix that code. That's a completely separate session in of itself. Again, my goal is to show you how you can find out certain things about those scenarios using Plan Explorer. All right. Now, if by chance you did wander into a advanced presentation and you're still a relative beginner to Plan Explorer, there's a huge a wealth of knowledge that's already out there, and this is a reference line. For what it's worth, all you really need to worry about or memorize is that GitHub address. All of my repositories are up there, and all of my presentations have an individual repository. So the latest version of this slide deck is available up there. So you can just jump over to github.com/SQLdeck, go download the slides there, and you'll be able to get at all of these resources. If again, you're not as, if you're not that advanced user already or intermediate user or whatever. All right, enough of that. And I'm also going to be monitoring the chat over here. And okay, I'll also address this before we get into anything else. A question that was raised: was SentryOne bought by SolarWinds? Yes. News is still breaking about that, but yes, we were just acquired by SolarWinds. It's going to be closing in the next week or so. But for what it's worth, my understanding is that Plan Explorer, as you know it, will not be changing. So all of this is still valid. There might be a rebranding, but I have no idea about that. But in either case, Plan Explorer is not going anywhere, and to my knowledge, it's going to be remaining free as it always has been. So I want to put any of those fears to rest. Okay. Let's get on with the presentation then. So SSMS versus Plan Explorer. A lot of folks, when they're first getting into using Plan Explorer, are wondering why bother using Plan Explorer? I can already get at execution plan information inside Management Studio, right? Well, I really like this particular quote. I think there are two steps in the evolution of a query: ensuring correct results and performance optimization. This quote is by Aaron Bertrand. Number one, or the ensuring correct results, is the role of realm of Management Studio. That's where you're going to be making sure that the query is returning the data that you want. But once you know that your query returns the data that you want, I want to kind of help you shift your mindset into leveraging Plan Explorer as not a development environment or an IDE, but a perf tuning environment. That's kind of how I like to start talking about it. And I'll show you some different ways that you can kind of remain in Plan Explorer rather than constantly jumping back and forth. Because I don't know about you guys, but what the workflow I used to do is that, I would run my code in Management Studio, and then I would just crack open the execution plan in Plan Explorer. But then once I see what I wanted to do, I would jump back into Management Studio, make the tweaks, rerun it in Management Studio, then jump back into Plan Explorer, and constantly be going back and forth. But if I'm at that performance optimization phase where I don't need to revalidate the results that are coming back, I can remain in Plan Explorer. And that's a mindset shift that I want to encourage everyone start thinking about. Plant that seed in your mind, and we'll see examples of this as we get into the demos. Okay, so the first chapter that I kind of want to talk about is customizing your UI. Okay, so a lot of us are working on, just single screens these days. I primarily work off of a laptop these days. And the thing about Plan Explorer is that it's a very information dense product. There's a lot of things going on because we're trying to bubble up a whole heck of a lot. And, because of limited screen real estate, if I wanted to, for example, expand the bottom index analysis tab, I'm going to have to squish some of the top windows. So then, my plan diagram now gets squished. I lose visibility on that. And that's a bit of a bummer. And there's only so much one can do about screen real estate. However, what a lot of folks don't necessarily realize, I didn't realize this for the longest time, is that you can actually grab and drag not only windows or sub windows or tabs, but whatever, and throw them onto other monitors. Many of us now, now that we're stuck at home, went out and invested in a second monitor, as I did here. And again, did you realize that you can kind of expand your horizons and take over all of your screen real estate? So if I were to zoom in a little bit here, notice on this right-hand monitor, for example, I happen to have, like the query columns tab, the index analysis tab over here, and then on the left-hand side, I've kind of stacked up the plan XML and the plan diagram, and then I have all the other typical tabs of information down here. But imagine if you have that massive widescreen monitor, or if you happen to have that multi-monitor setup, that you can go outside of the base window. See that this is where the base window is. Most of us only think within that particular container. You can drag elements outside of that. And that's what I want to encourage you to start thinking about when it comes to the UI. So with that, let's dive into the demo, and I'll show you how you can do some of that cool customization. All right, so for example, I'm just going to grab one of these different tabs down here. So actually, let me mention this. So when you're in a given window area, I can either grab the entire window with all of the different tabs along for the ride, or I can grab specific tabs down here. Okay, so I'm going to come down to the bottom, grab one of my tabs down here, and then I'll bring it up to the middle area, and then we'll zoom in here just to kind of show you the different options. So for example, if I were to drag and drop it here, then that would add this as one of the tabbed elements. So it would show up right here. Otherwise, I can stack it to the right or to the left, and then I can stack it above or below as well. I could also, for example, I'm going to stack it up over here to the right. And then for fun, I'm going to grab one of the other tabs over here, and I'll add that as a tabbed element right here. So you see how I've made some interesting modifications like this and this and this, for example. I can also grab the plan XML. One of the things I kind of like to do is make the plan XML one of the fully stacked elements over here on the right-hand side. So that way I can actually read the plan XML. So I can do something akin to this. Come on. There we go. So that way I can have the plan XML information available to me, because sometimes I really need to dig into that gory level of detail. And then I can always use the pin in, pin out to mess around with it. Now, if I start really messing around with my windows and I screw things up dramatically, I'm like, wait, what did I do here? I don't quite remember. Or you know what? I just want to go back to what the defaults happen to be because I've really, really jacked this up. Well, unfortunately, to my knowledge, there's no good way to reset the layout inside the application. What you need to do is actually close out Plan Explorer entirely. And then you're going to go to a folder. It's your user data folder, essentially, app data local SentryOne Plan Explorer. Don't worry, this URL reference is in a cheat slide later on in my deck, so we'll come back to that. But in either case, once you go to this app data folder, there's a layouts folder, an XML file, and another XML file here. All of these different XML files control different aspects of the layout. I don't know which one controls what, so you know what I do? I grab all three of these and I just delete them outright because Plan Explorer will recreate them with the defaults the next time it starts. So we've just wiped them out. Going to open up my PE session file once again. And now we're back at the defaults. So with the defaults in play, the one change that I always like to make is I like to put the plan diagram here in the middle as a tabbed element, mainly because I personally prefer to see the plan diagram in addition to the results. And then, I swap between the bottom tabs depending on what it is that I happen to need. Okay. So with that, the next thing I kind of want to talk about as far as the UI is concerned is some of the different elements up here in the results tab. So we have a lot of different columns up here, and let me actually do a little bit of setup, and then I will zoom in. 1, 2, all right. So we have a lot of different columns that are available to you up here. And first of all, the ones to the right here, like key lookups, missing joins, and things like that, things that are unfortunately now hidden underneath the that pop-up, are summary style data points. So it's basically telling you how many operators of a given type existed in your given execution plan. Like, for example, how many key lookups did I have? How many missing join predicates did I have? Hopefully 0, right? Or missing index recommendations or hash matches or sort operations, right? But with those columns, whoops, I apologize with the zoom in. With those columns, there's also the column chooser. All I have to do is right click on a column header. Column chooser is one of my options. And then as you can see, a wide variety of additional data points are available to me as well. And then all I have to do is drag them in and just drop them onto the grid. So explore some of these because there's a lot of really cool things that are actually hidden in the column chooser that we don't manifest by default. And for what it's worth, when I scroll here down to the bottom, the other place to make sure that you use the column chooser is for the plan tree tab and the top operations tab. There's all sorts of really cool extra data points that you'll want to include depending on how deep into the nitty-gritty details you want to get into your XML into your execution plans. Typically, people will crack open the XML when they want to see this type of information. But again, I want to let you guys know that it's available to you if you use that column chooser. So with that, the next little tip and trick that I kind of want to share is also to make sure to make use of our different filters. People are oftentimes don't realize that we have filtering capabilities. So I'm going to zoom in right here. I have the key lookup column hovered over, and you see a teeny tiny little icon that'll pop up. That'll pop up anytime you hover mouse over any column header in any of our different data grids. It's a standard in our different UI approach. But if I click on this particular guy here, I will be presented with the option to create a custom filter of some sort. But this is actually kind of a cool little discrete list of all distinct values. And you can use this as kind of a cheat sheet because, in this example, I have a whole bunch of different code here, right? So of the results, hey, I have some statements that had, 1 key lookup operator, 2 or 3 key lookup operators, so maybe I want to start with the ones that had 3 key lookups and then drop down to 2 and drop down to 1 as I'm sifting through all of these. So, and then you can use the custom filter option in order to do, greater than, less than, and all the other typical kind of filtering predicates that you might come to expect. So understand that that's available to you as well. And then one of the other things I kind of like to talk about is like, a lot of people will sort all this data and that sort of thing. And then they'll be like, you know what, I want to get back to the original sort order. I've sorted by CPU or reads or something like that. One of the obscure options that not a lot of folks make use of is reset sorting. If I click on this guy, it'll go back to the true execution order, or the execution that we collected each different statement in. So make use of the reset sorting. I have been asked what clear all sorting means. I frankly don't know, because as far as I can see, clear all sorting and reset sorting seemingly do the same thing. So I haven't bothered asking internally. So honestly, I don't know. I just use reset sorting. So yes, I work for SentryOne, and I still even have kind of like those head scratcher questions, or maybe it was one of those things that was implemented long ago and then people kind of forgot about it. I don't know. All applications have stuff like that. So in either case, that's how you can play around with the different filters and the sorting and that sort of thing. So make sure you leverage that. Okay, now let's return back to that quote from Aaron Bertrand. And I want to talk a little bit about making use of Plan Explorer as a performance tuning environment. Most folks, when they run code inside Management Studio, and I'm going to click on version 1 in my history tab, are used to seeing this. They'll run the code in Management Studio, use our little plugin to do the right click, open in Plan Explorer, and they'll see this kind of output, and this is typically what they'll see. But a lot of folks don't bother clicking on this command text window over here. This command text is where you're going to want to copy and paste in the T-SQL code, or type in your own T-SQL code, so that you can continue to execute whatever is in that command text inside Plan Explorer. You can run get an estimated plan, or actually execute the code, which will get actual plan, and so on and so forth. And you'll use that a connection, of course, to make sure that you're not connecting to production, because we don't necessarily want to play in production, right? Unless you really want to live dangerously, but I digress. In either case, so what I've done is that, so that's why I went to this, in version 1 in my history. So when I did this in version 2, here's the command text of the actual store procedure that I had originally run in Management Studio. I copied and pasted it over here. So a common question that I often get, is there any way to automatically get this information ported over? The answer is no. You do need the paid product for that. So that is one little bit of overhead. You have to copy and paste everything in here. But again, once it's all in here, you can then start leveraging it. But there's a lot of key advantages to starting to rerun your code inside Plan Explorer when you run it with Get Actual Plan, is that we can capture a heck of a lot more data. What do I mean by this? So let me show you the view that most of y'all are familiar with, which is version 1. Going to go to the Results tab here, and then we'll scroll up to the top. Sorry. Apologize about the zoom in, zoom out. I'm doing my best to be smooth about this. So we're seeing just, static statement level information, which is what I expect to see, right? This is what most of us are used to, is just all of the different select statements, or, DML statements, or whatever the case may be, and their corresponding information and metrics. However, there's different data points that are not necessarily fully available to us, because all we're getting is the information that's embedded inside the plan XML fundamentally. But if I were to run this inside Plan Explorer once again, I get even more information. One of the cool bits, and I'm going to do a bit of collapsing here just to kind of better illustrate this, is that this store procedure, remember in the command text, it was just one store procedure I was executing, but it actually executes a whole bunch of other store procedures. And now I can see that chain, that lineage. That's one extra element that we give you in here. If I were to scroll elsewhere within this result set, you'll actually see examples of statements that were also executed that do not generate an execution plan, like a declare, for example, or a while loop, for example. So now I can actually clearly see everything that's being executed, as opposed to just the things that create execution plans for us. So that's another cool element, an additional piece of information. I can also collapse all of these guys, so that way I can see it from that summary perspective of, which store procedure within this, the 10 store procedures I call are the ones that are causing me headaches, and then I can drill down into that, rather than just looking at it from a statement by statement flat perspective. So that's one of the key advantages. The other key advantage is that we collect session level weights for you here. So these are the session level wait times that were collected. So again, we can see all of that information here, okay? So that's one of the cool advantages. So I'm going to come back into the command text, and as a simple demo, select star from sys databases. So, we're commenting out the other code. I'm going to click on Get Actual Plan. And I love this little example, because if I time it right, not only do I get the select star from sys databases, but this is an example of how we capture even more information behind the scenes. if you're familiar with statistics, and when stats gets updated, you notice that stats got updated behind the scenes when we executed this particular select statement. So I'm able to grab all of that information, and now I can actually show you that, oh, something else happened here, or this is a good thing because we refreshed our stats, or whatever the case may be. So again, hopefully this example will give you a better sense of how you can stay within Plan Explore and use this again as a perf tuning environment, not necessarily a development environment, because we don't show you the results. We leave that to Management Studio. We do discard the results after the fact. But again, we collect a whole slew of other information as we are going along. By the way, for what it's worth, feel free to ask questions in the chat. I am trying to keep an eye on the chat over here on the left. So just taking a quick glance over. It doesn't look like there's anything there just yet, but feel free to ask questions as we're going along. I'm happy to go off on tangents and things like that. All right, so we've covered, a little bit of use around, the multi-call stack and that sort of information. Hopefully, you have a good appreciation of how I can use the history to constantly jump back to that prior iteration of what I was doing, because that's exactly what we're going to be doing to move on to the next chapter. And now I want to get into a common query pattern that a lot of us deal with, and that's parallelism. Oftentimes we encounter parallelism in our queries, and sometimes it's good parallelism, sometimes it's bad parallelism, right? So what I want to do is kind of show you how you can get at parallelism information inside Plan Explorer to help you make a better decision or conclusion about whether you want this parallelism to occur or not. So what I'm doing is I'm adding in an optional column real fast, and then I'm going to zoom in on them, and then I will explain what I'm up to. Okay, so degree of parallelism and parallel operations are already here by default. And then I just added parallelism operations. The difference between parallel operations is that parallel operations talks about the number of operators that went parallel, like an index scan operator went parallel, for example. Parallelism operations denotes the number of operators that are related to controlling parallelism, such as a gathering streams operator. So to better illustrate this, I'm going to go to parallelism operations. I'm going to do a quick filter, go to 3, and then the example that I want is, I believe, this guy down here. I'm going to jump down to top operations, and I'm going to resort the top operations by operation name. And notice that we actually will prepend the parallelism operations. Remember, I used the filter of 3 to now show you that we have a gather streams, repartitions, and 2 repartition streams operators in here. Okay, so that's how you see the parallelism operations, as opposed to the operators that went parallel are materialized by this checkbox over here. So why is this important to see? Well, sometimes you have part of an execution plan that goes parallel, but a different part of your execution plan may not go parallel for various reasons. There's various constructs out there that can prevent a portion of your code from going parallel. So, sometimes when you're troubleshooting a very expensive, analytical query or something like that, that you expect it to fully go parallel. Hey, wait a minute, why did this portion of the tree not go parallel? So I might click on one of these guys that didn't go parallel. It'll then pop up in the plan diagram, and then I can see the context of it and what else went beyond it. Like, oh, these 5 guys all didn't go parallel because of, all right, and that's all a portion of this tree right here. So question just came up. Does Plan Explorer show the cumulative time per operator? So there's a couple of different ways that you can see what's going on. You can show cumulative costs or per node costs right here and here, and then costs by IO, CPU, or that. Sorry. So we will either show you cost by an aggregate of CPU and IO, CPU or IO. We don't necessarily show you cumulative time per operator. So understand that that's slightly different, but frankly, I don't necessarily care about time. If I'm in the guts of performance troubleshooting, I'm really caring more about the work that's happening behind the scenes. But that's more my personal opinion than anything else. So this is what we're showing to you here. Okay, so hopefully that answers your question, and I'm going to mark this as answer live. Otherwise, I'm going to, where did my mouse go? All right, cool. So let's see. So we focused in on that. So the next thing I want to show you is inside, not the top operations tab, but the plan tree tab here. Inside plan tree, we have a couple of different data points that, so plan tree and top operations are very similar to one another. Plan tree, is showing me things, from the tree perspective. So it's got the whole hierarchy enforced and whatnot. But for whatever reason, I can't explain why, there are certain data points that are only available in plan tree that are not available in top operations. Some of the data points that are available in plan tree that I find extremely effective are the number of threads and the thread distribution here. So that's what I want to show you here. So this way I can have a better sense of, hey, this plan that went parallel, this operator that went parallel, was the workload relatively evenly distributed amongst the 4 threads, or do I have a unbalanced parallelism issue? Because that is a common scenario when you're dealing with parallelism issues. Because maybe you're seeing crazy CX packet weights. Are those CX packet weights just because a lot of parallelism is occurring, or hey, I only had one query running. Why did I get a lot of CX packet weights? Oh, I had terribly unbalanced parallelism. Because what if, thread 1 through 3, instead of processing, 750, 800,000 records, processed, 700 records each. And then it was the 4th thread that processed, hundreds of thousands, if not millions of records. That's definitely a case of unbalanced parallelism. And that would explain, or, show us that we have bad CX packets, packet weights coming into play, right? So this is an extra piece of information that I want to make sure that you guys definitely check out. So, sorry you got to bail, Jeff. Good to see you. Glad you were able to hang out with us. So I'm going to jump to a different example to kind of illustrate this. Let's see, I want the summary sales data, or is that one has the, yes, I am running off of a cheat sheet here. And for what it's worth, this cheat sheet will be fully available to you. It's all up on my GitHub. There's a slide at the end of this deck that also kind of details this particular cheat sheet. So the one I want to jump to is, I'm going to undo my filter. By the way, quick tip while I'm here. Sometimes when I'm looking at data, by the way, and I have a filter applied, I'll forget that I have the filter applied. So always look at the bottom of the data grid, and you can destroy or remove any and all filters that you happen to have here, especially if you make a change to your code and then you try and rerun get actual plan. And I'm like, wait a minute, why are no records coming back? Oh, because I had the filter in place. Whoopsies. All right, so parallels operations, I want 1, and then I want to go down to inventory fast. This is a fast parallel statement here. And I wanted to show you this example because this is one of those queries that runs really, really, really fast. And as you can see here, the parallelism distribution is a little more unbalanced. I don't like seeing this, right? But in addition to that, the other data point that I also want to mention is to go back to top operations. And inside top operations, we're going to go to column chooser, and I'm going to have you add an estimated total subtree cost. This is the unitless value that each operator happens to have. Query bucks, as some people calls it, Farkles that other people call it, right? But this number is, the number that you really want to look at to get a better sense of the overall cost of the query. So in order to figure out or resort down here in top operations, I always just go to estimated subtree cost percentage, sort that one. And then, so this is the max value, 35.94. Why am I bringing this up? Well, many of us have servers where the cost threshold for parallelism is still set to the default of 5. And industry-wide, we pretty much all agree that 5 is a terrible default. What you should change it to is a matter that's up for debate. A lot of us, myself included, suggest that you at least change it to 50 as a starting point and then tune based upon your workload from there. But using that 50 as that starting point, I can now get a better sense of, given this particular query here, did I really even want this guy to go parallel in the first place? Look at its total subtree cost. It's above 5, but below that general starting point of 50. This is a query that runs in great volume in my sample workload, or that's what it's meant to represent. That query that's run really fast, but run hundreds or thousands of times a minute. And if that thing is constantly going parallel, it's grabbing all the cores, it's doing just unbalanced parallelism, and there's that extra overhead of going parallel and then bringing all the data back together, the partition and gathering of streams, right? So this is a good example where if I know that this is something that goes parallel a lot and is run very, very frequently, I may want to force this to go serial. And again, this is why I want to show you, here's the pieces of evidence that you can go find to get a better assessment so that you can make that educated decision of how you want to change this particular piece of code. So that way you get parallelism when you want it versus parallelism when you don't want it. All right. So with that, let me just check to see if there's any other questions before we move on to the next table. Quick question. Well, let's show whether the logical I/O reads of work table, which great question. I'll get back to that later. So I'm going to hold on that one because I may be covering that later. All right. So for that, what we're going to, the next topic I kind of want to dive into is parameter sniffing. Parameter sniffing is another common anti-pattern that a lot of us have to deal with. So I'm going to remove my filter. I'm going to reset sorting because I want to go to a very specific example in this PE session file. So I'm going to scroll almost all the way down to the bottom. I will just resize my windows just to make this a little bit more readable. Give me a moment. And then I will show you the sample code that is being executed. Okay, so first of all, the pieces of code that are of interest. And again, remember, because I ran this inside Plan Explorer, I have the full call stack. So I have the declare and the set in here, which you typically would not see had you run this inside Management Studio and then ported everything over, because a declare and a set don't generate an execution plan. In either case, you see very clearly what I've all done here. So we're declaring, my state as Alaska. We're running this store procedure that passes in my state, which then executes this one select statement. We reset the my state value to Illinois, and then we re-execute the same store procedure once again. Let me just show you the text data of the statement in question. Blah, 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 blah. We're doing a whole bunch of stuff. Really, all we care about for the context of our discussion today is that we are using the state against a customer table. So, what's coming into play, what's controlling the volume of data that's being returned by the select statement is the number of customers in a given state, okay? So with that, if I scroll up here, and these are the two statements in question, notice that the first execution ran really, really fast, but the second execution ran a lot slower by a factor of 10. And I can very clearly see that my CPU utilization is a heck of a lot higher, and my I/O is definitely a heck of a lot higher as well. So, we definitely have some kind of problem here. And of course, most of us know that this is a classic parameter sniffing kind of scenario. Obviously, I already told you that that's what's going on. Now, oftentimes when people deal with parameter sniffing, they say, well, you know what? I'm going to go look at estimated versus actual rows. And I specifically use this example to show you that that's not always helpful, because notice that estimated and actual are identical in this case. The reason for that is that my sample query is an aggregation query. So I have a button, it's count, sums, blah, blah, blah. So the result set is always going to be one record. So this is an example where looking at estimated versus actual is not going to help you to determine that. So I just wanted to kind of share that nuance of that can be kind of misleading sometimes. But there's other good ways to see whether your estimated versus actual is completely out of whack. One of my favorite is to make use of this button up here called Show Estimated Plan. So I don't know about you guys, but whenever I use different tools, even Management Studio, I'll be honest, there are buttons that I've never tried and pressed, and I have no idea what they do. Especially go look at like Word or Excel. There's like tons of stuff up in the toolbar. I have no idea what it does, and I'm ashamed to say that for many years I never really messed around with this button, so I had no idea what it did. Well, it's actually really cool, and I kind of wish I had discovered it sooner. So many of us will look at an execution plan, and I'm going to kind of zoom in on a segment here. I'll minimize this just to kind of give you that better visualization, right? So, we'll look at an execution plan, and we're looking, Plan Explorer's of course got the line bar thickness and things like that, right? And we're seeing the actual execution plan. If I click this button, you'll see things change. Now, there's not much change here because I chose the Alaska variation, but now if I jump down to the Illinois version, zoom on in, ta-da! You see how the line bar thickness has suddenly changed between what we estimated, like a few hundred rows to come out of the clustered index scan from the customer versus 189,000 rows, which was the actual, right? So I love using this now just for that quick little, hey, I'm going to look at the execution plan just from a high level perspective. I'm not going to read the details, and I'm just going to flip back and forth just to see if anything pops out to me as suddenly switching back and forth. Like, oh, hey, wait a minute. That line, which used to be really, really narrow, is now really, really thick, or vice versa, right? So that's one quick way that I'll, because remember, estimated versus actual only tells you the summary, of the entire execution plan. But again, in my aggregation example, there's only one record ever. But this way I can very quickly see that, oh no, there's estimation type issues further on down inside the inside my execution plan. So that's just one of those kind of quick tips. Make use of that. And for what it's worth, if you don't care to use that, you go, just go into top operations, the actual versus estimated rows. You see that we will actually highlight those places where there's a lot of skew between the estimated and actual on the operator level. So make use of that as well to, again, get a better sense of, hey, are things completely whack or not? Okay, so because this is a parameter sniffing scenario, we do have a parameters tab down here. And the parameters tab doesn't tell me much, but it tells me one key bit of information. We had a parameter whose compiled value was one state, and my runtime value was a completely different state. Okay, so now I'm definitely suspecting a parameter sniffing issue based upon this. The next thing I would typically do is jump back into Management Studio and do a quick select count count state from customer group by state, right? To see what is my data distribution. But you don't necessarily have to do that. In fact, I'm going to advise that you not do that, because when you're doing that select from the customer table, you're only going to be looking at the data. But remember that the query optimizer doesn't look at the data when it comes up with your execution plan. It looks at statistics. So really what you should be doing is looking at the statistics histogram to see what the stats say it believes is your data distribution. It believes is a key statement there, right? Because your stats could be completely out of whack, right? Maybe your stats for some reason weren't updated in 6 months or something crazy like that. So the cool thing is that I can now come over to index analysis instead of jumping back to Management Studio. So I'm going to switch my selected operation to the customer operation here. I'm going to select on, I got to click on state. I will mouse over this guy here, and then we'll zoom on in. Okay, so the bottom area is the statistics histogram inside index analysis. And for what it's worth, everything you see inside index analysis is unique to Plan Explorer. So if nothing else, use Plan Explorer just for index analysis. And one of the reference bits on that reference slide is a really awesome blog. And there's a video out there by my teammate, Devin. She did a phenomenal write-up about index analysis and why she loves it. Okay, status histogram. So for those of you that are outside the US only has 50 discrete states. So this makes for a simple, easy example. The orange bars here represent the number of different values, and all you have to do is just kind of eyeball it to see that Illinois has a heck of a lot versus many of the other states. If I scroll further to the right, there's a couple of states that have a bit more data, but for the most part, everyone's pretty static around here. And then Alaska doesn't even register on the chart. There's so few customers in Alaska, right? So that's what you're seeing here. And then inside the tooltip itself, you see that the high, I've moused over and selected, the Illinois element inside the histogram. So now I can see the estimated number of rows versus the actual that we wound up pulling out, and so on and so forth. So I have all of this information that's available to me here in the histogram. So now I can clearly see in the histogram without having had to go back to Management Studio what my data distribution is. So now I'm even more convinced that, yeah, this is definitely a parameter sniffing type of scenario. So let's see. So yeah, we covered that. We covered that. We covered that. So while I'm here, up here is where we can use index analysis as kind of that little sandbox, right? So, we got, this table only happens to have a clustered index. It actually does have a missing index recommendation that was generated by the query optimizer, right? And a lot of people are like, oh, just use the missing index recommendations. I've been in environments where people will blindly apply all missing index recommendations. It's actually one of the reasons why I developed one of my earlier sessions that's half about missing index recommendations, missing duplicate redundant indexes. You can go search search around for that. There's recordings of that session elsewhere. But in either case, you can mess around and see the missing index recommendations. But the other cool thing is that if this table had other non-clustered indexes, you would see those materialized here as well. So that way you can quickly do a quick bit of reference and see, based upon that missing index recommendation, there may be this other non-clustered index over here, and I can kind of mess around with that and add that or something like that, or just change that existing non-clustered index if I wanted to. The other thing I want to show you is visible columns. By default, indexed columns and used in query columns are highlighted. What's not is the other column here. So this way I can now see all of the columns that are part of the customer table. So I can get a better sense of what's going on inside that customer table. So if I want to make index changes based upon this missing index recommendation, I might say to myself, well, I know my data well enough where, yeah, it'll make sense to make a state a non-clustered index with the leading key of state, but I also might know my data well enough to know that I'll need to add in first name, last name, and city, and address as included columns, for example. Or in addition to state, maybe I want state and zip followed by zip code, or state followed by city, for example, in order to make a better functioning non-clustered index. So you can make use of all of this to play around with that. Also note, last statistics update. So when was the last time stats were updated? Because again, sometimes that is just the nature of your problem. It has absolutely nothing to do with the underlying data. So were your stats updated last in 2019? Whoops, maybe my index maintenance broke or something like that, right? So things that you may want to look into. When you see last stats update on this area, it's on these are column level stats. And then for the index stats, I got to scroll down here. When you're looking at a given index, this is where the last stats update will be materialized here. So again, you can check that out. And this is especially useful if you're working in a dev environment or a staging environment, because many of us are not going to be trying to replicate things that happen in production. We're going to be doing this type of stuff in a staging, QA, or dev environment. So while prod may have your maintenance jobs doing regular updates, what if staging or QA's stats are completely out of whack because they don't have the same equivalent maintenance jobs? You may have ported down the same database or used some kind of mechanism to restore prod to dev, prod to staging, or something like that. But again, if your stats are out of whack for whatever reason, that's something to keep in mind. So that's one thing I'd really want to draw your eye to. And for what it's worth, you can use this shortcut button to update stats. So it'll generate the code to do that for you. So you can do that right there. Let's see. And you know what? I am gonna go back and do the missing index recommend. Oh yeah, sorry. This side is the update stats one. This is the missing index of scripts. So this is an example where I am gonna create that missing index recommendation. I'm gonna execute this guy right here because I'm gonna live dangerously. And this is where I'm gonna just copy and paste out the different cells into the command text so that we can rerun the code. Just so again, I can kind of show you how this workflow works. So I'm gonna copy this guy here into the command text. And then I'm just going to redo this manually, set this to IL. And this way you can prove to the people that say, oh, just apply the missing index recommendations. That'll magically fix everything. No, it won't. Those of us who know better all know that it will not. But hey, I can now see everything that's running and see, as it goes through here. All right, query execution has completed. We can very clearly see just by looking at the runtime metrics that things have not gotten better at all. And then if I come back to index analysis, we still did, sorry, customer table. Where did it go? There it goes. So in the customer selected operation, and I will do this. So in the execution plan diagram, hey, we did use that missing index recommendation. That should have magically fixed everything. No, in this case, it didn't. This is a parameter sniffing situation. So even though we had that missing index recommendation, it didn't do jack to help us out. By the way, what's the IO? There was actually a question earlier, and this is a good time to kind of show that. Well, there is a table IO tab down here. And table IO will actually show you the equivalent of set statistics IO information. And part of the question was, will we see, unintentional use of tempdb? Well, just like you see in set statistics IO, it'll show you work table, work file. You see all of that information here. And, the work table and work file in this context came out of different spool operations that occurred in the context of this particular execution plan. So this is me coming back to that earlier question that I said I'd be punting on. And by the way, did we actually at least get an improvement out of the reference to the customer table? Well, remember, so in this case, logical reads 288. Remember, I can go back in history. So I'm going to jump back in history, go back to that original statement, and then we'll zoom in here. Well, yeah, at least we did reduce IO against the customer table. So that's a little bit of an improvement. But again, did we address the underlying issue? No, we did not. But something's better than nothing. And, baby steps is sometimes the case when it comes to perf tuning. So, it's an iterative process. Make use of that history to be able to jump back and forth. Because I don't know how many times when I would be living in Management Studio using statistics as IO, it's like, oh, I forgot to write down those numbers. I got to go back and rerun the prior query and that type of headache. The history tab is a huge lifesaver for, again, referencing what did I do 2, 3, 4 steps back, especially as I'm iterating through a given solution. All right. So with that, I'm going to switch examples to also talk about one other element about about index analysis. And for that, I need to go to key lookups. We're going to go to operators or statements, I should say, that happen to have one key lookup. And the example that I want is this guy, I believe. Yes, it is. Okay, so when I come back to index analysis, I need to select the inventory seek, and I need to select this guy here. Okay, so what this code is doing is that, it's doing some aggregation stuff and whatnot, but it's going after data inside this inventory table based upon a VIN number, okay? Let me do this real fast just to show you the execution plan. So it's actually doing seek operations into the inventory table based upon a given VIN number, but it's actually doing multiple seeks, a bunch of singleton seeks. We can see that because it has a nested loop operator here, and so it's done 14,000 different index seeks to go get that VIN number. So one thing I want to talk about is something called the tipping point, because within the tipping point, we have a behavior where SQL Server will choose to do an index seek plus a key lookup operation if the non-clustered index in question does not fully cover a query, meaning it doesn't have all of the data points that are needed by this query. So what is the trade-off? Is it cheaper to do an index seek and a costly key lookup? Or do I just say, forget it, I'm just going to scan the entire inventory table instead and do a full table scan? That's one of the common questions when people are dealing with indexes and they're like, why didn't SQL Server use my index? And like, because I put it on the key column, for example, and I'm searching on the key, it's because you're trying to look up other things and you're hitting that tipping point because your query or your index doesn't fully cover the query. And, again, where is that trade-off of the key lookup? And that trade-off is something called the tipping point when it comes to indexes. And this is something, and we now visualize the tipping point inside index analysis. This is a relatively new feature. So this is kind of what I want to demonstrate with you. So even though we're doing a whole bunch of different index seeks, we're only doing effectively singleton index seeks here. So when I come down to the statistics histogram, let me actually do a quick mouse over. I'll do it right here. Okay, so this pinkish bar right here represents the tipping point range. So we do some internal calculations to say if the estimated number of rows falls somewhere between here, SQL Server may go one way or the other. If it is above the tipping point, then SQL Server will choose to do a full table scan. If it is below the tipping point range, then it will definitely do an index seek and a key lookup operation. But Andy, you pulled back 14,000 records. However, that's why I pointed out inside that execution plan, because we're doing a nested loop join, that we're doing singleton seeks. So the estimated will always fall underneath, even though my total actual happens to be way above the tipping point here. So this is a case where, had we not, had the query optimizer not done this, it would have actually gone the other way. So, this is a case where estimates were a bit off because, again, the original estimate was that I'm only going to be doing one VIN number, and there's other problems with this piece of code, which is why we have this particular behavior here. But understand that you can get at this particular bit of information if you're seeing those key lookup operations. So I kind of wanted to point out this tipping point bit, and If you're not familiar with that, Kimberly Tripp of SQL Skills has a phenomenal blog out there that really gets deeper into the tipping point. Our founder, Greg Gonzalez, also had a really good blog that really introduces this concept that he published when this new functionality was rolled out. Okay, so make use of Plan Explorer to also get at the tipping point. Okay, so let's see. So the next demo that I kind of want to do is something called live query profile. Sometimes we have those ridiculously long statements that, or statements that take a long period of time, like this simple select statement here. Oh, that's a simple select statement. It's not going to do much right here. So I'm going to click on Get Actual Plan. Oh, again, I forgot to turn off the filter. Actually, let me stop this and redo it again one more time. There we go. This is what I wanted to illustrate to you guys. If you have that ridiculously long, statement that, it takes a ridiculously long time and you execute it inside Management Studio, you have no idea what SQL Server happens to be doing. You can do things like SP who is active to see the active statement, but you can't get additional details on that. If you do this inside Plan Explorer, however, we have this cool thing called Live Query Profile. So now I can actually see the flow of data as what's going where, as it goes. So in this case, we're spending time right now pulling in data from the inventory table, and we're sending it back up the chain inside this particular execution plan. So I can watch the pretty charts here as we progress here. So this is actually pretty cool. So again, something where, I executed in Management Studio, it's a black box. Try executing it inside Plan Explorer and make use of this functionality to give you even more information about what's going on. Now, I'm going to click on stop. This particular statement that I used, select from VW all sold inventory. So of course, we're selecting against a view. And if you know me and any of my other presentations out in the community, you know I hate views, or really, or more to be more accurate, I hate nested views. And this is actually an example of a terribly, terribly nested view. Because in fact, if you look at the plan diagram, we're going against a whole bunch of different tables here. But one thing that we do in Plan Explorer is we present to you the join diagram. This is kind of the raw, flattened breakdown of all of the different tables that you're going after underneath. What this join diagram does not show you is if you go after a given table multiple times. So understand that aspect of it. So in either case, though, I can still see the different relationships and so on and so forth by looking at this flat join diagram. Now, if I want to get a better sense of how many times I'm hitting one of these given tables, that's where I want to take you back to top operations. So I'm going to take you back to top operations, and I'm going to resort by object. And let me expand this out. So now that I've resorted by object, we can see, for example, I have done 2 full table scans of the inventory table. Why did I go after the inventory table twice? That's kind of silly. Not only did I do that, but I went after the vehicle color table, the vehicle make and model table, and base model table twice as well. So it's like, I already read the data once. Why am I reading it all in its entirety again later on, or in a different portion of the execution plan, right? That's kind of silly. But that's one of the things that can potentially and often, unfortunately, oftentimes happen when you have inefficient nested views. SQL Server is not able to simplify things enough, or whatever the case may be. And I actually have a whole other presentation that kind of delves into that. In fact, 2 presentations that delves into what the Query Optimizer is doing. One is about I/O performance, or understanding I/O inside the storage engine to increase T-SQL performance, and the other one is performance pitfalls of code reuse, essentially, nested views, scalar UDFs, and that sort of thing. So if you want to find those to dive more into that particular topic, you can do that. Okay, and I just mentioned scalar UDFs, and that's actually a great transition into my next demo. But let me pause for a second to see if there's any new questions that came in. I answered that one live. It doesn't look like there's any questions. Okay, cool. So let's continue on. Next demo. So I have a piece of code here that also represents one of my other key nemesises in the T-SQL world, scalar user-defined functions. So, I'm just doing a simple select top 20, but we have 2 scalar user-defined functions: calculate net profit, calculate sales commission. I'm going to execute this guy right here, get actual plan. Okay, so what's cool about doing this inside Plan Explorer is that we will show you all of the different individual statements that are executed inside each of the different scalar user-defined functions. And of course, in addition to that, I see the underlying, IO, CPU, and duration as well. So, even though our total duration was only, 2.2 seconds, I can see that a lot of it, was consumed or composed of these other statements that were being executed behind the scenes in its own context. Oh, hey, I didn't know about that. Additionally, I can also add in this optional column. So I'm going to go up to column chooser, and let's see, I want to grab object name. So object name will now tell me the parent of where a given statement originated. So now I can clearly see that we're executing calc net profit, calc sales commission, and then we're repeating ourselves row by agonizing row. And if Jeff were still here, I'd give him a shout out because he's the man who coined rebar, but of course he had to bail out. Yay, Jeff. Anyway, so this is a clear example where I can see that kind of behavior. So that's kind of cool. On the other hand, there's a drawback here. I'm going to click on one of these different statements. And unfortunately, with this given statement, I cannot see the execution plan. And this is actually a behavior within SQL Server because essentially the code that's inside those scalar UDFs is essentially run in its own context. And as a result, or a result of how Microsoft does it behind the scenes, the execution plan does not bubble up to us. If you were to do this inside Management Studio, run this the sample piece of code and say get actual execution plan, you will see the same exact behavior. So this is not something that we can do any magic around. It is, again, not exposed to us because of the way Microsoft has implemented this. That being said, I can get estimated execution plan, in which case I can at least see what the Query Optimizer came up as an estimated plan. But once I do that, I lose the hierarchy. I don't have the associations. So unless I knew this code, I have no idea which of these statements came from what given object. So this has its own drawbacks, but I can at least see what the estimated plan looks behind the scenes. So understand that there is a little bit of nuance when we are dealing with scalar user-defined functions. Okay, let's see. So I covered that and I covered that. So I believe we are now moving. Okay, so second to last demo here, and then we're going to be wrapping up. So we talked a lot about execution plans and what Plan Explorer can do for you. But did you also know that Plan Explorer can also help you dissect your deadlocks? That's one of those like, oh, hey, I didn't realize that. And of course, it's not in the name. So most people don't realize that until they actually see it in action. So I'm just going to go over to Management Studio, which is, whoops, over here. There we go. I have this piece of Deadlock's code out there. I don't know if I'm really going to bother to run it. Basically, I just have a job that kicks off a couple of other jobs, and that will eventually cause a deadlock. And then I use extended events to grab that deadlock information. So once I grab that deadlock information, one of the columns that will come up is the deadlock graph, which is XML. I'll right-click, save as an XML file, and now I can open up that XML file inside Plan Explorer, which is exactly what I'm really going to be doing now. So deadlock graph number 1. And that deadlock graph is available up on my GitHub as well, if you don't happen to have any deadlocks convenient for you to play around with. So in either case, and also this is a great way to share deadlocks with others. Hey, on the prod DBA, I found this deadlock we had in prod. Grab the XML, send it down to development, and tell them to open it up in Plan Explorer. Okay, so in either case, let me kind of explain how we break down a deadlock for you. We have one given SPID in play. And then when I first open up this SPID, people expect to see additional SPIDs because that's what you typically see in like a blocking chain or something else like that. But in our case, we show you a deadlock from the perspective of the resources that were being fought over. So in this case, we have object locks on elements inside the customer, inventory, and sales history tables. And then when I expand one of these guys, then we have 2 subcategories, owners and waiters. SPID 60 in this case owned something, owned this particular element, and then SPID 58 wanted that particular element. And the reference point that you're going to want to make note of is the mode and the type over here. So the first guy had an exclusive lock, and this is 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 what, intent shared or something like that. So I don't, all those types are the standard abbreviation types for out of SQL Server. Go look them up in Microsoft.com, because I always look them up because I don't have all of them memorized. You would think those are one of those esoteric things that I still haven't memorized after all these years. In either case, I can further expand these guys out to see the underlying T-SQL that's in play. Just going to keep expanding this. This is where, again, having those multiple monitors could be really nice so that you can expand all this good stuff. So in this case, this is SPID 60. Here's the underlying T-SQL, and this is just a contrived example of of code to generate a deadlock scenario. And I can keep expanding each one of these to kind of see what's going on, right? To see the underlying code. For what it's worth, a lot of folks are always wondering, how does a deadlock actually choose its deadlock victim? Well, it takes two different values into play. This is deadlock priority, and then this is the transaction log written on a given SPID. So it'll look at the SPID and it'll look at the deadlock priority. Deadlock priority is one of those hidden values that I didn't even know existed for the longest time. It's always defaulted to value of 0. You have to use a query hint if you want to set it to something else. But in case of ties, which is most of the time, then SQL Server will look at the transaction log written for a given statement. Whichever statement or whichever SPID has written the least amount of transaction log will be chosen as the deadlock victim. Or as I like to joke, SQL Server is lazy and wants to do the least amount of work rolling back, right? So that's how you interpret that data to figure out why was this one chosen as the deadlock victim as someone else. It wasn't completely random, okay? All right, so down here, we have a really cool diagram that shows you a visualization of the deadlock as it occurred, because oftentimes deadlocks I find happen because application code is occurring in such a rapid sequence that it steps on one another, right? And sometimes you need to see that order of operations, the order of events as they occur, to get a better understanding of, oh, I can't allow these things to happen simultaneously, and because they wind up stepping on each other. Maybe in my app code, I need to implement some kind of queuing system. So it's like a first in, first out, or some kind of gating system, or some kind of locking mechanism that will then prevent this. So to help you visualize this and understand the sequence of events, I can click on the play button down here. And I have this really cool little animation bit that shows me the sequence of events as they occurred. So I see that SPID 59 took an exclusive lock on the inventory table. 58 took an exclusive lock on the sales history table, and so on and so forth. And then, I click on play again, and I see that each of these guys now want another lock on something else that someone else is holding. Eventually, the deadlock is detected by SQL Server, and then SPID 60 is chosen as the deadlock victim in order to resolve the deadlock. But that's how you can use Plan Explorer not only to look at your execution plans, but also to check out and dissect your deadlocks. All right. So with that concludes the demos at this point. And so let me do a little bit of wrap up, and then I'll go check out the chat to see if there's any other questions, and I can hang out as long as you all want as far as answering other random questions about Plan Explorer. Okay, so this particular slide is more of just a recap about the UI chapter that I covered early on. The most important thing is just that URL reference in case you want to reset your layout. And then, just want to leave you some parting thoughts. It's my distinct hope that after this particular presentation, you have a better appreciation of how you can use Plan Explorer as a performance tuning environment, that you don't need to be constantly jumping back to Management Studio, that you can remain there and discover some really cool things. If you want to recreate everything that I've done, there's a PE session up on my GitHub, the demo notes, the deadlock diagram, and of course, a PDF version of the slide deck. This presentation, though, is constantly evolving. I only debuted it, like 2 months ago, and I've already made a ton of changes. So if you come back to my GitHub in say 2-3 months, there may be new demos in there because I've been constantly refining the demos, making little tweaks to the demo notes and that sort of thing. That's one reason why I still have to use a cheat sheet, because again, things have constantly been changing. But again, it's really my hope that you have a better appreciation of how you can leverage Plan Explorer, even if you've been using Plan Explorer for many years like myself. Maybe you've learned a thing or two. That's my hope. But with that, I'm going to quickly check out the chat. Deadlock is my pirate name. That's awesome. I love it. I've seen some people that have really crazy, insane deadlock diagrams with literally hundreds of SPIDs in play. It makes a really, really cool diagram that's really pretty and really, really scary. All right. Hey, thank you. I'm glad to hear that you learned some tips. That's really cool. For what it's worth, guys, we are asking, so thank you very much, by the way, but for what it's worth, I am going to ask something of all of you guys. Would you mind taking just a moment in the chat and giving me a quick +1 or a -1 if this session did meet your expectations or it did not meet your expectations? Just give me that quick bit of feedback. It's, with us being virtual and all, it's a lot harder to kind of gauge the audience. And, I can't tell if all of y'all are sleeping out there or what. Hopefully y'all are, I've been able to keep y'all engaged. But yeah, if you wouldn't mind, just take 2 seconds, give me that quick +1, -1. And if it is a -1, if you would be courageous enough, tell me how I can improve this session too. Because again, as I told you, it's constantly evolving. But again, I'm also happy to take additional questions and even go back into other stuff, related to whatever as far as Plan Explorer is concerned, because I believe I officially have another 30 minutes to burn.
You do,
wow,
and
I clocked in a lot faster than I thought. This presentation, sometimes goes a little bit longer, it goes a little bit slower. I'm like, oh, okay then. So wake up, Amy. Is there a dark theme planned for Plan Explorer? Not to my knowledge, I'm afraid, which is sad to me. I'm a big dark theme fan, but it is not on our roadmap. Awesome. Thank you so much. Jan, thank you so much for that bit of feedback. I really appreciate it. Brandon, I hope you have some fun playing around with Plan Explorer for the rest of the day. And again, my contact information is down there. If you have other questions about Plan Explorer, feel free to please hit me up. Let's see what else we got going on here. So is Andy best or the PE? Should we rate that too? Feel free to rate it as you like. So what's the difference between get estimated and show estimated? Great question. So when you, let me jump back to here. When you get estimated, that means you're going to run whatever is inside the command text, and you're going to run it against management or run it against SQL Server in order to get a fresh estimated plan out of SQL Server. This is the equivalent of inside Management Studio doing the display estimated execution plan functionality. So it's exactly the same. On the other hand, the button that I was showing you of show estimated plan requires that you have already gotten an actual execution plan. So if you look at the history of the type here, the E versus the A will show you whether a given history entry was estimated versus actual. That's why right now we have the estimated guy here highlighted. Sorry. And show estimated plan button is currently grayed out because we're already showing you the estimated plan. We have no actual to show you. So if I go back to one of these guys that is the actual, then I can flip back and forth between show estimated versus show actual. So, the estimated plans behind the scenes, what did SQL Server think was going to happen? What were the estimated values? And then what really wound up happening. So that's the difference between show estimated versus get estimated. I hope that helps out. All right, awesome. What else is
I actually have a question for you, Andy, if you don't mind. What was that tool you were using to illustrate the arrows and box things in? Because it was great, the Zoom feature for accessibility as well. Like, I was a really big fan of it. And just for other potential speakers, I'm sure it'd be really helpful for them as well. Is that part of Plan Explorer in some way, or what is that?
This is all Zoom It. This is all Zoom It magic. So hang on, I'm trying to figure out if I can Zoom it using Zoom It.
It's like
so I
dividing by
actually
zero, be
cannot,
careful.
because now that the window is open, I can't actually zoom right now, which is the irony of this. So many of us in the SQL Server community are big fans of Zoom It. Zoom It is a completely free tool, so a lot of people will use this for zooming, but what I really love using this for is the drawing functionality as well. So I might be able to do a draw right here. No, I cannot, because the window is open. But I love the drawing, and I remember sitting in a presentation long ago, long before I ever became a speaker, and I don't remember who it was, but it was someone I really looked up to at Microsoft, and he never left the lectern, but his presentation was all demo, and it was all Zoom It action with arrows and everything, and it was so smooth and so elegant. I'm still choppy, obviously. I kind of bounce back in and out.
I thought it was Zoom and elegant myself. I thought it was elegant, if I have to say.
I still strive to be that perfection of elegance with Zoom It that I saw that one day. Maybe that's that unicorn in the sky, you know what I'm saying? But nonetheless, it's one of those things where I love using the draw functionality, especially when, because like, even if when you're up on stage, people try and use a laser pointer, but not only people can always see the laser pointer, or, I can leave the arrows, up on the screen for a while longer as I talk through something, right? So I really, really, really love the draw functionality. But again, that's just my personal opinion.
No, that's awesome. Thank you. I was curious too, because I'm just like, I do a lot of tutorial videos for things, and I'm like watching these arrows pop up, and I'm like, this is so much easier than a series of screenshots with me just drawing circles around it. So I'll keep that in mind. Thanks.
Yep. And let's see, there's a couple of comments in the chat. SSMS does have a compare plan feature. Yes, that is correct. We currently do not do direct plan comparison capabilities, but I would still argue that you're sometimes better off staying here, because you can jump back and forth into history, and there's a heck of a lot more information that we collect behind the scenes. But sometimes you do just need to see a plan side by side. So yeah, feel free to use Management Studio for that. In Azure Data Studio, Plan Explorer is giving the same information as standalone application. No, unfortunately. So the Azure Data Studio Plan Explorer version technically is still a beta, if I recall correctly. It's not a full-blown version of Plan Explorer yet. We're waiting to essentially see more adoption with Azure Data Studio by SQL Server developers, and we're starting to see that. So the V1 that you happen to have right now is to kind of get something out the door. And last I checked, which was a while ago, there are some quirks with Azure Data Studio of just getting the Plan XML out. Because if you can at least get the XML out, then you can just drop it into Plan Explorer and then continue on your way as you traditionally would have had you been working with Management Studio. But with ADS, there is some kind of quirk that I experienced with XML extraction where it would put quotes around everything, therefore breaking the XML. And I kind of gave up after that point, playing around with it. So thank you for the comment about or compliment about being more fluid watching the Zoom in annotations and whatnot. So I'm glad that worked out for y'all. So thank you so much for that. Any other questions or comments or heckling or whatever? Don't be shy in the chat. I have thick skin. All right, doesn't sound like there are any. So if nothing else, I'm going to put in a shameless plug for the upcoming keynote with Vicky Harp. That'll be in what 20 minutes?
Yep, 20 minutes there on the DBA track. I'm actually about to drop a message for anyone that's looking to join. You can join with one click. We're not going to be featuring content on this track during the keynote, so it'd be really great to attend.
And the other thing I also want to make a bigger shout out for is the keynote by Andy Mallon later today. That's a non-technical keynote, but you know what? Diversity and diversity type issues are something that we all have to deal with, whether we want to admit it or not. And now is as good of a time as any to start thinking about these types of things. And Andy, has been an advocate for a very, very long time now. And I'll be honest, I'm really looking forward to this keynote because I'm really kind of curious to see what he's got to say and some of the new things he's going to bring to bear as far as a formal presentation around this. So do make the time later today to check that one out especially. So I want to encourage all of you guys to do that. But otherwise, thank you so much for joining me. I hope you enjoy this presentation on Plan Explorer. I really appreciate y'all spending some time with us. And